On a clear night, how many stars can you count? Hundreds? Thousands? Or even more? Do you know what stars are made of? Have you ever wondered how far away all these stars are?
1, 2, 3, 4.
Shuttle Columbia, this is Mission Control. Excellent launch. Prepare for the long journey ahead.
That's a Roger, Mission Control. Everything looks great from here.
These kids are on a special space mission to learn all about stars. Okay, so they're not really traveling to space. Especially not this astronaut in training. But they are practicing a real-life space mission, sending astronauts up to check out a space telescope. Space telescopes can see some very distant stars. Mission Control wants you on this special mission to do some important star research.
Shuttle Columbia, you need to find out. What are stars? How many stars are there? Which star is closest to Earth? And how do scientists study stars?
So fasten your seatbelts and hang on tight. We're headed for a close-up look at the stars.
There are billions of stars in outer space. In fact, there are more stars in space than there are grains of sand on all the beaches in the world. So, if you tried to count all the stars, one by one, it could take you millions of years.
Did you know that our sun is a star? In fact, it's just one of billions of stars that belong to the Milky Way galaxy. A galaxy is an enormous group of stars, dust, and gas held together by the force of gravity, the same force that keeps us on the ground and holds our own solar system together. Most every star we see at night belongs to the Milky Way galaxy. The Milky Way galaxy is spiral in shape, or sort of like a giant pinwheel. It wasn't until 1924 at the Mount Wilson Observatory in California that Edwin Hubble, an astronomer, proved that there were other galaxies beyond the Milky Way. There are actually billions of other galaxies in the universe. Some we can see using telescopes, but most are so far away that we can't see them, even with the most powerful telescope. These galaxies come in many different shapes and sizes, and each one is filled with billions of stars. Our sun looks different than the stars in the nighttime sky, but that's because it's much, much closer to Earth than any other star in space. Our sun provides us with light to see and heat to stay warm. Without the sun, life as we know it on Earth just wouldn't be possible. All stars give off light and heat, and all stars, including the sun, are made up of hot gases. The gases are held together in the shape of a ball by the star's own gravity. At the center of a star, temperatures reach over 1,000,000 degrees. These high temperatures cause one gas, called hydrogen, to turn into another gas called helium. When hydrogen gas turns into helium gas, explosions happen and a flash of energy is released. This energy is sent out in all directions as light and heat, the same light and heat that we receive from our sun here on Earth.
Booster ignition and liftoff.
If you were to travel from Earth to the Sun by space shuttle at top speed, the journey would take you about 7.5 months. Sure, that sounds long, but if you were to take a space shuttle to the next nearest star, called Proxima Centauri, the trip would last over 160,000 years. Now that would really be a long trip. Mission Control, Shuttle Columbia here. We have a really great view of the Big Dipper through our starboard window.
Roger, Shuttle. And it looks like you are right on course for rendezvous with the Space Telescope.
The Big Dipper, the Little Dipper, Orion the Hunter, the Southern Cross. Do these names sound familiar? These are the names of constellations, which are patterns of stars in the night sky. Thousands of years ago, ancient astronomers drew imaginary pictures around groups of stars and made up stories about them. This way, it was easier to remember which star was which. Orion was a hunter in Greek legends and is one of the brightest constellations in the sky. Orion is easy to find. 3 bright stars in a row are said to be Orion's belt. The stars that make up Orion look like they're close together, but they're not. In fact, they're really very far away from each other.
At night, it seems like stars are all the same distance away from Earth. But how we see stars really depends on 3 things: how big they are, how bright they are, and how far away they are. You might think that this star is the closest and that this star is the farthest away. But look, just because a star is the largest or brightest, that doesn't mean it's the closest. And just because a star is small or dim, doesn't mean it's the farthest away. And check this out. Even though stars seem to group together, like in constellations, that doesn't mean they're actually next to each other. It all has to do with the size, brightness, and distance of the star.
If you've ever watched stars for a while at night, you can see that they appear to move as a group across the sky. But it's really just another trick on our eyes. The stars aren't moving, it's Earth that's moving. The Earth constantly spins like a top as it travels around the sun. However, there is one star that doesn't appear to move at all. That's Polaris, better known as the North Star. It is located almost directly over the North Pole. So while all the other stars appear to move, Polaris stays put. If you want to find Polaris, lay a compass flat on your hand. When the needle stops spinning, it will be pointing north. Look up in the sky in that direction. Then try to find the Big Dipper. The Big Dipper is a constellation of 7 stars that looks like a water ladle. Once you find it, follow the 2 stars on the outer end of the Big Dipper's bowl directly up to a bright star. That's Polaris, the North Star. And it happens to be the last star in the handle of the Little Dipper, another constellation you may have seen before. Long ago, when ancient sailors were at sea, they always looked for Polaris. If they sailed toward it, they knew they were going north. If they sailed away from it, they knew they were going south. Pretty neat that this little star, way up in the sky, always helped them find their way home.
Have you ever seen a streak of light in the night sky? That's a shooting star, which actually isn't a star at all. Another name for a shooting star is a meteor. Meteors are made when pieces of rock, metal, and dust enter Earth's atmosphere. The meteors burn up, which cause streaks of light.
For hundreds of years, people have been using telescopes to look at the stars, galaxies, and other mysterious objects in our universe. Telescopes use magnifying lenses and mirrors to make faraway objects look bigger and closer. Early telescopes were about as powerful as a pair of modern binoculars. But today's telescopes are much bigger and better. Observatories are special buildings that hold some of the largest telescopes. They're located all over the world. Most of them are high on the tops of mountains where skies are very dark because there are no city lights nearby, and the view of the horizon is clear in all directions. Observatory telescopes allow astronomers to see 3,000 times further into space than we can see on our own.
Telescopes use mirrors to collect and focus light from stars. Want to see how they work? Try this. You'll need some plain white paper, tape, a flashlight, a comb, a large shiny spoon which will act as our mirror, and a magic marker. Tape a piece of paper to the edge of a table. Turn off the lights. Lay the flashlight on the paper. Take the comb and place it in front of the light. You should see a series of light rays spreading out from behind the comb. Place the spoon in front of the light rays so that the back of the spoon is facing the flashlight. Use your marker to trace the pattern of light rays you see on the paper. Do you see how the light rays curve outward? Put that page aside, and with a new sheet of paper under the flashlight, have the light rays shine into the bowl of the spoon. Trace this pattern. Do you see how the light rays curve inward? Now compare the two pieces of paper. Both types of mirrors are used in telescopes, but do you know which one is used the most? Well, the job of a telescope is to collect light from faraway stars and space objects. Mirrors that are curved inward, like the bowl of a spoon, collect the most light. So, they are the kind used in many telescopes to help astronomers see faint objects in space. These telescopes are called mirror or reflecting telescopes because the mirrors in them reflect light.
Shuttle Columbia, this is Mission Control. You are about to come alongside the Space Telescope.
Mission Control, this is Shuttle Columbia. We're all ready for the capture.
In order for astronauts to work on the space telescope, they'll have to leave the shuttle and go on a spacewalk. That's why these astronauts in training are putting on special spacesuits. They need protection when they're outside the spacecraft. Here are real astronauts floating way above the Earth and about to work on the Hubble Space Telescope. Stars are too far away to send spacecraft to explore, so that's why scientists built the Hubble Space Telescope, named after the famous astronomer Edwin Hubble. The Hubble is a very powerful telescope. It helps us to see objects far, far away in space. Astronauts took the Hubble with them on the space shuttle and put it far above the Earth's clouds. Clouds and atmosphere sometimes block the view of telescopes on Earth. But in space, there's nothing to block the Hubble's view, so more light from the stars can reach the telescope. The Hubble Space Telescope also works as a camera. It took these great shots. This is the Pistol Star. This is the Eagle Nebula. And these are two galaxies colliding. After the Hubble telescope takes pictures, it can send them by satellite to the scientists back on Earth. When the Hubble telescope was first put into space, it sent back fuzzy pictures. That's because the main mirror on the Hubble wasn't working properly. Astronauts had to go back up and correct the problem.
Wow, how about that?
This is what pictures looked like when Hubble was broken, and this is what they looked like after Hubble was repaired. Astronauts continue to visit the Hubble every few years to make sure it is in perfect working condition, and that it continues to send gorgeous pictures back to Earth of distant stars, galaxies, and other space objects we have never seen before. Now let's take a look at what stars really look like up close. From the ground, stars look white or yellow, but scientists have known for a long time that stars are different colors. There are blue stars, white stars, yellow stars, orange and red stars. The difference in color actually tells us how hot the star's surface is. The hottest are blue, and the coolest are red. It's like a fire in a fireplace. Have you ever noticed different colors of fire between the logs? The blue flames are actually hotter than the yellow ones. And the yellow ones are hotter than the red ones. But hey, no matter what color a star is, it would be too hot for us to visit in person.
Stars are not only different colors, they're different sizes too. From Earth, they look like tiny points of light, but really, they're huge. Let's say this is our sun. It's big, 1 million times bigger than our planet Earth. But it's not the biggest star out there. Some stars can be over 100 times larger than our sun. And some stars can be 1,000 times smaller than our sun. Hard to believe that that big yellow ball in the sky, our star, the sun, is just a medium-sized star.
Stars are not permanent. Over billions of years, stars form, then burn, then slowly grow, and then burn out. When a star is first formed, it is very bright, hot, and usually blue in color. But soon the star settles down and gives off a steady amount of heat and light. Our sun, a yellow star, is in the middle of its life. Scientists predict that it will burn for a very long time, at least another 5 billion years. Near the end of a star's life, it turns red and becomes much larger and cooler. After that, many stars shrink and then burn out. However, not all stars follow the same path. Some really huge stars live a shorter life. They burn fuel so quickly that sometimes they are destroyed in one tremendous explosion. This event is called a supernova.
Even though the sun is our closest star, you should never look directly at it. Not with an ordinary telescope, not with binoculars, not even with a pair of sunglasses. The sun is so bright that if you look right at it, you might hurt your eyes permanently.
1, 2, 3, 4.
Mission Control to Columbia. You are on course and are go for landing.
Roger, Mission Control. We have the runway in sight.
Welcome back to planet Earth. Your mission is almost complete. Just one more thing. It's time to report back to Mission Control. Are you ready?
What are stars?
Stars are made up of very hot gases, hydrogen and helium, that are held together in the shape of a ball by the force of gravity. When hydrogen gas gets very hot, it turns into helium. This creates a powerful explosion which releases light and heat in all directions. At the center of a star, temperatures reach way over 1 million degrees.
How many stars are there?
There are billions and billions of stars in outer space, more than grains of sand on all the beaches on Earth. Most of the stars we see at night belong to our own Milky Way galaxy. an enormous group of stars, dust, and gas held together by the force of gravity. But there are billions of other galaxies out in space, all with billions of their own stars. In order to remember which star is which, astronomers have grouped stars into imaginary patterns called constellations. However, even though stars may look like they're close together, they're usually very far apart from each other.
Which star is closest to Earth?
Our sun is much closer to Earth than any other star. That's why it looks so much bigger than the rest of the stars in the night sky. Even so, it is still a hot ball of gas that gives off light and heat, just like all other stars. Still, without the sun, life as we know it on Earth just wouldn't be possible.
How do scientists study stars?
Because stars are so far away, scientists use really powerful telescopes to get a good look. Some use telescopes on the ground, and some rely on space telescopes like the Hubble to look deep into space. Telescopes have revealed a lot of important facts about stars. We've learned that stars are a range of colors, from blue to yellow to red. The color of a star is determined by how hot it is. Blue stars are the hottest, and red stars are the coolest. We've also learned that some stars are much bigger than our sun, and some are much smaller. Finally, we've learned that when stars are formed, they burn, grow slowly, and eventually die out. This normally happens over billions of years. But this doesn't always happen. We also saw that some of the largest stars can burn fuel so quickly that they create a truly dramatic explosion called a supernova.
1, 2, 3, 4.
Shuttle Columbia to Mission Control. We have touchdown.
Mission Control to Columbia. Roger. Nice job, gang. Welcome back.